Hello, thanks for joining us today for a demonstration of the new AMQP 1.0 proxy functionality in the Form Sentry API Security Gateway. The Form Sentry API Gateway enables code-free point-and-click building of APIs to integrate legacy and modern systems, connect cloud and mobile technologies, and extend business applications and services securely beyond the enterprise border. Today's session will focus on Sentry's no-code interface while highlighting features such as protocol mixing, transformation, and inline data security. The Form Sentry API Security Gateway converges three key functions of technology: security, identity, and integration. This demonstration of the AMQP 1.0 features in Sentry will pull from each of these categories. For API security, we'll demonstrate SSL, schema validation, threat detection, digital signatures, as well as payload level encryption. For identity, we'll look at multiple user authentication options and credential translation. And then lastly, for integration, we'll highlight JSON to XML transformation and HTTP to AMQP 1.0 protocol mixing. This session will cover two different AMQP 1.0 proxy scenarios. Both will utilize Form Sentry as a secure API gateway, essentially acting as a reverse proxy that sits between a client application and a backend AMQP server. The first scenario will feature Sentry as an AMQP proxy with both sides of the transaction, the client and the server, utilizing the AMQP 1.0 protocol. We'll use a Java AMQP 1.0 client that'll put a message through Sentry to an active AMQP service. Sentry will perform the following on the incoming request: SSL termination, JSON schema validation, SQL injection detection. It'll convert the document from JSON to XML. It'll then do document-based user authentication. It'll map a transaction ID into the new XML document. It'll encrypt the payload, it'll sign the payload, and then it'll translate that user credential into a SASL format that'll be required on the active AMQP service. Now let's review the policy configuration in the Sentry point-and-click web admin interface. We'll start by reviewing the network policies in Sentry, which are like the plumbing to get the traffic into and out of Sentry. To receive the incoming AMQPS requests, we have a listener policy in Sentry. Within this policy, we can specify the IP and port for Sentry to listen on, as well as set IP access control restrictions, user authentication requirements, and the SSL termination settings. Once the message has been received by Sentry, it'll be processed at the content policy layer. More on that later. For now, let's talk about the network remote policy, which will be used for Sentry to connect to the active AMQP service and send the processed message. Inside the network remote policy, we can again specify authentication options that are required by the remote server, set SSL initiation policies, enable verbose logging, and set timeout values. Now, sitting between the two network policies is a JSON policy. JSON policies are a type of content policy that are designed to process JSON message flows. This JSON policy consists of a virtual URI, which is the Sentry virtual endpoint for the service, and a remote URI, which is where the actual active AMQP 1.0 service resides. The virtual directory ties together the listener and remote policies we previously reviewed. Within the JSON policy, on the task list tab, we have a task list associated, which will be used to implement a lot of the processing outlined earlier. This includes validating the JSON schema, detecting SQL injections, converting the JSON to XML, validating the document-based user credentials, injecting a transaction ID into the message, signing and encrypting the payload, and then lastly, setting some AMQP headers. To demonstrate the functionality we've discussed so far, let's send a message through Sentry to the active AMQP 1.0 service. For this, I'll use a Java app that's based on Apache Cupid to put a JSON payload through Sentry. When I run the app, we'll see the connection happen and then the request message printed out. However, before we run it, so let's take a look at our active MQQ. We're using Q1 here. We'll notice that the number of pending messages is 0. After we run our client app, that will increment to 1. So let's go back and actually run the application. We'll see the connection happen and the actual JSON message being printed out that was posted. And if we go back to our ActiveMQ queues, we'll see the Q1 count is up to 1. And if we actually inspect the message, what we'll see here is the processed message. So we'll see the XML document, so the JSON to XML transformation succeeded, and we'll see within that that's a signed and encrypted document. We can then open up our Sentry system log and refresh it, and we'll see that transaction in the Sentry log. If we scroll to the bottom, we'll see the beginning of the request. We'll show everything from the AMQP headers coming in to the JSON request payload. And then we'll also show all the task list processing that's happening in Sentry, the validation, the conversion, signatures and encryption. And then lastly, we'll show you the processed message, which is the signed and encrypted XML payload that's being sent out to the ActiveMQ AMQP SQ. So this is the first use case where, again, AMQP is used on both sides of Sentry, and Sentry is acting as a proxy in the middle, performing the security, identity, and integration features we've talked about, and then passing that message along down to the ActiveMQ AMQP service. The next use case we'll look at is Sentry again in the middle, but this time we'll use an HTTP client that'll post a message into Sentry. Sentry will then do all of that same processing of that JSON payload and send that message along down to the ActiveMQ instance using AMQP protocol. So this is an HTTP to AMQP protocol mixing use case. Again, Sentry will be used for security processing, starting with the SSL termination, JSON schema validation, SQL injection detection. It'll then convert from JSON to XML. It'll apply a user authentication, map the transaction ID into the XML, encrypt the payload, sign the payload, do the user credential translation, and apply that SASL user authentication with the remote server. Lastly, Sentry will be doing HTTP to AMQP 1.0 protocol mixing to complete the use case. So now let's review the Sentry configuration for this second use case. We have a JSON policy here for the HTTPS to AMQPS protocol mixing, and you'll notice the virtual URI is HTTP or HTTPS, and the remote URI is AMQPS. Okay. We also have a task list defined here. We have the same task list on the request processing to take that JSON payload and convert it to XML, sign and encrypt it. We also have a response processing task list here. So the HTTP client, when it posts a message, it's a synchronous transaction, so it's expecting a response. So we actually have Sentry generating a static response document and then injecting a dynamic transaction ID into that response document, which will be returned back to the HTTP client when we test it. So to test this service, we'll use SOAP Sonar, which will post a JSON document through Form Sentry, which will then process that message, send it along to the ActiveMQ AMQP service, and Sentry will then generate a response document, send it back out to my client. So we can go ahead and send a request through, and what we receive back here is our transaction result with our transaction ID. This transaction ID matches the transaction ID for this particular session or message in the Sentry system log as well. And so we can send a couple through here, and we'll see that that transaction ID will change every time based on the logging in Sentry as well. And if we go and look at the actual ActiveMQ queues, we'll see that the queue count is continuing to grow as we send messages through. So right now it's at 7. If we send another one through here, we'll see that's going to increment to 8. So we know that the messages are getting through Sentry, and we know that Sentry is converting the JSON to XML and signing and encrypting that simply by looking at some of the messages that are in that queue. But some of the processing that Sentry is doing are things like schema validation and SQL injection detection and user authentication. So let's go back to our test client here and generate some messages that should fail in Sentry and ensure that Sentry indeed blocks those messages. So the first thing we could test is the schema validation. So I can come in here and actually remove a field from my JSON payload, send this message into Sentry. Sentry fails immediately and shows failed to validate JSON. You can completely customize the errors that come back from Sentry. And if we look at the Sentry system log, we'll see in yellow that error message as it comes in. So the request comes in, we immediately fail, and this message never makes it to the ActiveMQ service. We can go back here. Let's repair our document. So we now have a valid transaction coming through. getting our valid response. And then let's change the actual document-based username. So we have an actual static user and password stored in Sentry right now that's doing this validation. Typically, you would tie Sentry into your existing identity management platform, like an LDAP, Active Directory, database, SiteMinder, TAM, whatever you use to store your users. Sentry will integrate with and cache the results. We come in here and actually just change this name, add a couple of extra characters, and send this through. Sentry will block this immediately and return back an unauthorized request. And likewise, we can check the Sentry logs to ensure and see where that failure occurred. So let's go back to a valid request here, send that through, make sure things are working again as expected. And now we can test the SQL injection detection by using a value here that will trigger the default pattern match regex values in Sentry. So we send this through and we'll notice the failure immediately is a pattern match block coming back out of Sentry. So we can see that our malware detection is happening, we can see the user authentication is happening, and we can see, of course, that schema validation is occurring as well. So everything we've built here in Sentry today, all of these policies for AMQP proxying, whether it's an AMQP client or an HTTP client coming in with all the task lists that we've defined, all of this is portable. You can export these policies from one Sentry and import them into another. And in fact, we have template policies very similar to these up in our knowledge base. So this concludes our demonstration today of the AMQP 1.0 features in Form Sentry. We looked at two use cases. The first was an AMQP client putting a JSON message through Sentry. Sentry converts that to XML, signs it, encrypts it, and sends it via AMQP to an ActiveMQ system. The second was an HTTP client putting a JSON message through where Sentry processes that message, sends that along to an AMQP backend system. If you have any questions, please feel free to visit us at www.forumsys.com. Thanks a lot. Have a great day.